In this video, we're going to use the unit circle to estimate two numbers with a given trig value. Let's start with part A. We have sine of t is equal to 0.2. Using our circular function definition, we see that sine of t is equal to y. So what we want to do is to find all the points on the unit circle that have a y-coordinate of 0.2. So we come over to the y-axis and we locate 0.2 horizontally across to find one point, and then go across to the left and we find a second point. And what we need to do is to measure the arc lengths that correspond with those 2 points. So for the first one, we start at 0 and we measure counterclockwise. And it looks like this is approximately 0.2. Now if we continue going around the circle, we get to our other point, and it's just before 3. I'm going to estimate that that's about 2.9. So for part A, we have two answers. One of them is 0.2, and the other is 2.9. Now to verify these answers, we can use a scientific calculator. First of all, double check and make sure that your calculator is in radian mode. We're not using degrees anymore. First, let's find sine of 0.2. And we can see that it rounds to 0.2, so that looks good. And then the other value was 2.9, so we find sine of 2.9. And that also rounds to 0.2, so we did pretty well. We could also use the calculator to get these values more precisely. You might recall that to find angles, we use inverse trig functions. So if we find the inverse sine, or the arc sine of 0.2, it comes out to be approximately 0.2. And then to get the other angle, we would take pi and subtract the arc sine of 0.2. And that comes out to approximately 2.9. Now to see why that works, you can see that if we go halfway around the circle, we get to a little bit past 3.1. That's actually pi. Pi is 3.14. And then what we need to do is to take away this little piece in here, and that's 0.2. So take pi, subtract 0.2, and that gives us the 2.9. Next up, we have part B, where the cosine of t is equal to negative 0.6. So looking at our definition, we see that cosine of t is equal to x. So what we need to do is to locate the points on the unit circle that have an x-coordinate of negative 0.6. So we find negative 0.6, and then we go up vertically until we hit the unit circle, and we also go down vertically until we hit the unit circle. So we can see that this first point is at approximately 2.2, and the point at the bottom of the circle is about 4.1. So our two solutions for part B are 2.2 and 4.1. Ready for part C. We want to find out what are the values of t where tangent of t is equal to 4/3. Looking at our definition, we see that tangent of theta is y over x. Now it might be tempting to think that our y value is 4 and our x value is 3. But if we were to try and plot the point 3, 4, we'd have to go over 3 on the x-axis and up 4 on the y-axis, and our point would be way up over here on the right. So what we have to recall is that tangent is the ratio of the y value to the x value. And so from a previous lesson, we learned that the slope of a line is equal to the tangent of theta, and in a unit circle, theta and the arc length are equal to each other. Remember that S is equal to R times theta. And in this case, our arc length is a value of t. Our radius is 1. And then we have theta. So in a unit circle, the arc length and the angle both have the same measures. So in this case, we have m is equal to the tangent of t. Another way of writing 4/3 is 0.4 over 0.3. So on our unit circle, we could start at 0, 0 and go up 0.4 and then over 0.3 and then go up 0.4 and over 0.3. And we finally reach a point on the unit circle, and this is at about 0.9. Similarly, we could go down 0.4 and to the left 0.3, down 0.4, left 0.3, and we get to about 4.1. So it looks like for part C, our answers are 0.9 and 4.1. Notice that our values are in the first quadrant and the third quadrant, and we know that tangent is positive in the first and the third quadrants, so that looks good.